The responsibility for evaluating and adding an arc flash warning label to panel boards generally falls on several parties. Firstly, the electrical engineer, often acting as a consultant, typically has the primary responsibility to conduct an arc flash hazard analysis and determine the appropriate warning labels. Secondly, the panel board manufacturer may include generic arc flash warning labels based on standard configurations. Thirdly, the installer is generally responsible for installing warning labels as specified by the electrical engineer or the manufacturer. To perform arc flash calculations, the IEEE Standard 1584 is often referenced. This standard provides detailed guidelines and equations for calculating arc flash hazards. However, because this standard can be expensive, there are alternative options to consider. One option is to use free arc flash calculation tools. There are several free online calculators available, such as the Electrical Apparatus Service Association, or its arc flash calculator, or the Schneider Electric Arc Flash Calculator. It is important to verify the accuracy and limitations of these free tools before relying on their results. Another option is to use commercial software programs that can perform arc flash calculations. Examples include SKM Power Tools or Easy Power. These programs often provide more comprehensive analysis capabilities compared to free tools, but they require a software license. Alternatively, you can hire a qualified electrical engineer to conduct an arc flash hazard analysis and provide warning labels. This option can be beneficial if you lack the expertise or resources to perform the analysis yourself. It's also useful to consult additional resources such as the NFPA 70 Standard for Electrical Safety in the Workplace, the Electrical Safety Foundation International, and the International Association of Electrical Inspectors. These resources can provide valuable information and guidance on arc flash safety. Arc flash is a dangerous phenomenon that can occur when electrical equipment malfunctions, creating a high-energy explosion and intense heat. Arc flash warning labels are crucial for alerting personnel to the potential hazards and providing information on how to mitigate the risks. The information displayed on an arc flash warning label typically includes the nominal voltage of the equipment, the arc flash boundary, and the incident energy level. The arc flash boundary is the distance from the arc flash source at which a person could receive a second-degree burn if an arc flash were to occur. The incident energy level is the amount of energy that a person would be exposed to at a specific distance from the arc flash source. It is expressed in calories per square centimeter. Understanding these parameters is essential for selecting appropriate personal protective equipment or PPE. When working on or near energized electrical equipment, it is crucial to wear appropriate PPE to protect against arc flash hazards. This may include flame-resistant clothing, a face shield, gloves, and other protective gear. The level of PPE required depends on the incident energy level and the specific tasks being performed. It is also important to follow safe work practices, such as energizing equipment whenever possible and using insulated tools. Regularly inspecting and maintaining electrical equipment is also essential for preventing arc flash incidents. Over time, equipment can deteriorate, increasing the risk of malfunctions that could lead to an arc flash. Therefore, establishing a comprehensive electrical safety program is vital. This program should include regular training for personnel, hazard assessments, and the development of safe work procedures. By implementing these measures, you can significantly reduce the risk of arc flash incidents and protect workers from serious injuries. The NEC or National Electrical Code provides guidelines for electrical installations to minimize fire hazards and electrical shock. While the NEC does not explicitly mandate arc flash warning labels in all situations, it does address electrical safety and safe work practices. Some local jurisdictions may have additional requirements for arc flash labeling. It's important to consult with local authorities and industry standards to ensure compliance. There are specific methods to use to determine incident energy. Arc flash calculation tools use equations based on various factors such as voltage, current, clearing time of overcurrent protective devices, and working distance. The IEEE Standard 1584 provides the most comprehensive guidance on these calculations. The specific equation used to calculate incident energy varies depending on the equipment configuration and the available fault current. Arc flash studies involve collecting data on the electrical system, performing calculations, and generating reports that detail the potential arc flash hazards. These studies are typically conducted by qualified electrical engineers with expertise in arc flash analysis. The results of the arc flash study are used to determine the appropriate warning labels and PPE requirements. It's important to update arc flash studies periodically, especially after any changes to the electrical system. Changes such as adding new equipment, modifying protective device settings, or altering the system configuration can affect the arc flash hazard levels. The frequency of updates should be determined based on the specific circumstances and industry best practices. In some cases, mitigation techniques can be implemented to reduce the arc flash hazard levels. These techniques may include reducing the clearing time of overcurrent protective devices, increasing the working distance, or using arc-resistant equipment. Reducing the clearing time can be achieved by using faster-acting fuses or circuit breakers. Increasing the working distance can be accomplished by using remote racking devices or other tools that allow personnel to operate equipment from a safe distance. Arc-resistant equipment is designed to contain the energy of an arc flash, minimizing the potential for injury and damage. Ongoing training and education are crucial for maintaining a safe electrical work environment. Workers should be trained on the hazards of arc flash, the proper use of PPE, and safe work practices. Training should be conducted regularly and updated as needed to reflect changes in technology and industry standards. A well-trained workforce is better equipped to recognize and avoid arc flash hazards. Proper labeling can help minimize risk. Arc flash warning labels should be clear, concise, and easy to understand. They should be placed in locations where they are readily visible to personnel who may be exposed to arc flash hazards. The labels should be durable and able to withstand the environmental conditions in which they are installed. Regular inspections of arc flash warning labels should be conducted to ensure that they are still legible and in good condition. Damaged or missing labels should be replaced promptly. The arc flash boundary is the distance from energized electrical equipment within which a person could receive a second-degree burn if an arc flash occurred. This boundary is calculated based on the incident energy level and the thermal performance of the clothing worn by the worker. The greater the incident energy, the larger the arc flash boundary. It is important to stay outside the arc flash boundary unless you are wearing appropriate PPE. The incident energy level is the amount of thermal energy that a person would be exposed to during an arc flash event. It is typically expressed in calories per square centimeter. The higher the incident energy level, the greater the potential for injury. Incident energy levels are determined through calculations based on factors such as voltage, current, and clearing time. Electrical safety audits are an important part of an effective electrical safety program. These audits involve a systematic review of electrical equipment, work practices, and safety procedures to identify potential hazards and areas for improvement. Electrical safety audits should be conducted by qualified personnel with expertise in electrical safety. The findings of the audit should be documented and used to develop corrective actions. Implementing a comprehensive electrical safety program requires a commitment from management and the active participation of all employees. Management should provide the resources and support necessary to implement and maintain the program. Employees should be trained on the program requirements and held accountable for following safe work practices. A successful electrical safety program can significantly reduce the risk of arc flash incidents and create a safer work environment for everyone. When selecting PPE for arc flash protection, it is important to consider the incident energy level and the arc rating of the clothing. The arc rating is a measure of the clothing's ability to withstand an arc flash event. It is expressed in calories per square centimeter. The arc rating of the clothing should be equal to or greater than the incident energy level. Flame-resistant clothing is typically made from materials such as Nomex or treated cotton. These materials are designed to resist ignition and prevent the spread of flames. Flame-resistant clothing should cover the entire body, including the arms, legs, and torso. In addition to flame-resistant clothing, other PPE may be required, such as a face shield, gloves, and hearing protection. The specific PPE requirements depend on the incident energy level and the tasks being performed. Regular inspections of PPE should be conducted to ensure that it is in good condition and provides adequate protection. Damaged or worn PPE should be replaced immediately. Using the right tools and equipment helps. Insulated tools are designed to protect workers from electrical shock when working on or near energized electrical equipment. These tools are typically made from non-conductive materials such as fiberglass or plastic. Insulated tools should be inspected regularly to ensure that they are free from cracks, damage, or contamination. Grounding equipment is used to provide a safe path for fault current to flow back to the source. This helps to prevent electrical shock and reduce the risk of arc flash. Grounding equipment should be properly installed and maintained. When working on or near energized electrical equipment, it is important to use appropriate lockout/tagout procedures. Lockout/tagout procedures are designed to prevent accidental energization of equipment while it is being worked on. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned back on. Following proper lockout/tagout procedures is essential for preventing electrical accidents. Developing and implementing emergency response plans is important in the event of an arc flash incident. These plans should outline the steps to be taken to evacuate the area, provide medical assistance, and investigate the cause of the incident. Emergency response plans should be practiced regularly to ensure that everyone knows what to do in the event of an emergency. Reviewing past incidents is a key step. Analyzing the root causes of past arc flash incidents is essential for preventing future incidents. This involves gathering information about the incident, identifying the contributing factors, and developing corrective actions. Findings of the incident investigation should be shared with all employees to prevent similar incidents from occurring. Contributing to a safety culture helps. Creating a culture of safety is essential for preventing arc flash incidents. This involves promoting a safe work environment, encouraging employees to report hazards, and recognizing and rewarding safe behavior. A strong safety culture can help to prevent accidents and create a more productive work environment. Staying informed about the latest industry standards and best practices is important for maintaining a safe electrical work environment. This involves attending training courses, reading industry publications, and participating in professional organizations. By staying informed, you can ensure that you are using the latest and most effective safety practices. Collaboration is key. Working with qualified electrical contractors and consultants can help to ensure that your electrical system is safe and compliant with all applicable codes and standards. These professionals can provide expertise in arc flash analysis, PPE selection, and electrical safety program development. Consulting with experts can help you to reduce the risk of arc flash incidents and create a safer work environment. Consider the voltage level of the electrical equipment. Higher voltage equipment typically poses a greater arc flash hazard. Understand the available fault current of the equipment. Higher fault current can result in more severe arc flash events. Note the clearing time of the overcurrent protective devices. Faster clearing times can reduce the incident energy level. Evaluate the working distance from the equipment. Closer working distances result in higher incident energy levels. Consider the equipment configuration. Different equipment configurations can affect the arc flash hazard. Properly maintain electrical equipment. Poorly maintained equipment is more likely to fail and cause an arc flash. Ensure that overcurrent protective devices are properly coordinated. Proper coordination can help to reduce the clearing time during a fault. Use arc-resistant equipment where feasible. Arc-resistant equipment is designed to contain the energy of an arc flash. Implement remote racking procedures. Remote racking can allow personnel to operate equipment from a safe distance. Provide adequate training for personnel working on or near energized electrical equipment. Training can help workers to recognize and avoid arc flash hazards.